So here's a throwback one more time to Math 20. Yeah, I just can't let go of Math 20. Right. Anyways, reference angles. You did this last year. We know this. How do I know this? Why does this sound familiar? Because a reference angle, here's the big long definition for it, is the angle in standard position. Okay, so that's one of the reasons why we have to learn standard position. It has to be a positive and it has to be acute. So it's got to be less than 90 degrees. We actually even give it its own symbol. We say theta r, reference. But here's the important thing. It's formed by the terminal arm and the x-axis. Uh-oh, now that's the important part. So if you're here, that's simple. There's the reference angle, which happens to be the same as the standard angle, right? Okay. But what if you went all the way around to here? Guess what? That ain't no way. That's not an acute angle. That's way over an acute angle. But check this out. There's your acute angle. Why? Because you're always with the x-axis. So there's the reference angle. There's the reference angle. And that becomes incredibly important when it comes to measuring things. Oh my goodness, when we get heavy duty into solving equations and stuff like that with radians, oh, if you don't know reference angles, everything goes to heck in a handbasket real fast. So how do we do this? How do we figure out what that angle is? Well, this one, just read the angle off. The theta, whatever you got here, is the theta reference in quadrant 1. But in quadrant 2, think about it. You're going to go to 180 degrees, and you're going to subtract whatever this guy is to give you the balance. So take 180 degrees, subtract off your original theta. That gives you your reference angle. Well, we'll look at it as we go. Take a look. You might get the flavor for this when we look at the next couple. Quadrant 3, right? Again, from the x-axis. So you're going all the way over. How much did you go over? That's the reference angle based on the x-axis. So, okay, so how much did you go over? Well, take off the 180 degrees that you went over here. Okay, take off the 180 degrees. You get the reference angle. Look at this one. Same kind of idea. If you go all the way to here, remember, you don't care about this. That's not what you're measuring it with. You're measuring it with the x-axis. So how much left then to make 360 degrees? Well, simple. Take the 360, subtract what you had, gives you your reference angle. You'll get the hang of it as soon as I throw a couple of questions at you. Okay, so let's stop wasting time. Let's get to the questions. It says, find me the reference angle for each of the following angles of rotation. Okay, no problem. First thing, 120 degrees. Why don't you draw it? That really helps. 120 degrees. Okay, so there's 90. 180 is out here. So 120 has got to be out this way, somewhere in there. And that's just a really rough sketch. Now think about it. How much is left? How much is left? Well, it's easy. Take the 180 degrees, take the 120 off there, you're left with 60 degrees. There's your reference angle. So theta reference would be 60 degrees. That's simple, right? Yeah, no kidding. Okay, let's take a look at this one now. Look at 375. Again, you have to be smart. You have to be smart. Look, going all the way around is 360, isn't it? Uh-huh. All right, so keep on going. How much do I have left? If you think about it, subtract this 360 from this, you're left with 15 degrees. Guess what? That's 15 degrees. That's not only just your principal angle, smallest positive angle, but that also is your reference angle. So theta reference is 15 degrees. That's nice. Well, how about this one? Oh, my goodness. Oh, my goodness. Well, let's start talking about those wonderful multiples again. Okay? So knock 360 off this, right? 360. The next one would be, of course, 720, and so on and so on and so forth. Okay, so let's look. 720. Okay, what's left? What's left is negative 60 degrees. Okay, let's draw it. Boom. Negative 60 degrees is down here. Negative 60. Okay, so what's the reference angle? Easy, 60 degrees, right? Just get rid of the negative. This reference angle works out to be 60 degrees. Oh, how nice, right? You getting this? This is so easy. Okay, so what happens when we now start talking about radians? Well, guess what? Common denominator time. So take a look at the denominators. Figure out the common denominator. All right, 2 pi over 1. This is now 3. So, okay, this will be 6 pi, right, over 3. Perfect. Look at this one. That'll be 2 pi over 1 multiplied by 4. This is going to be our 8 pi over 4. How about this one? That's 6, okay? 2 pi multiplied by 6, that's going to be our 12 pi over 6. Now, shop and compare. Look at that. Let's go to the first one. Dun, 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 8 pi over 3. So if you think about it, 8 pi over 3, according to this, you must have gone around already. Think about it, because going all the way around is 6 pi over 3. You've gone an additional, guess what? 2 pi over 3. So you went an additional 2 pi over 3. But where does 2 pi over 3 end up? Where do you end up with 2 pi over 3? This should be interesting. How does this work? Well, this is where you got to start thinking again, right? Look, here's your circle, your unit circle. If you go all the way over to here, right? Think about that. In terms of 3, that's 2 pi over 3. 2 pi over 3, right, has to be right around, well, okay, wait. That's pi. That must mean that this is 3 pi over 3. Well, where's 2 pi over 3? Well, there's 1 pi over 3. 2 pi over 3 has got to be over here. Think about it. You must have gone all the way to here to make 2 pi over 3. So what's left? What's left to get to 3 pi over 3? Yeah, you got it. Pi over 3. There's your reference angle. So in this case, theta reference has got to be pi over 3. Oh, that's a little complicated, isn't it? Yeah, well, maybe, not really. Okay, let's go do another one. Maybe this will clear it up for you. Same kind of idea. 15 pi over 4. Now, we're talking 8 pi over 4. Well, the next stop is 16 pi over 4. Think about it, right? Right? The next one would be 16 pi over 4. But what is this? Okay, stop. Let's talk. 8 pi over 4 means going over 4 pi over 4. 8 pi over 4. What's left? Another 7 pi over 4. That's what's left. Think about it. That's 8. We're going 15 pi over 4. Where's 7 pi over 4 going to be? Well, there's 4 pi over 4. Add some more. 7 pi over 4 is probably going to be somewhere around there. It's got to be in the fourth quadrant, because another pi over 4 will get us back to our little home base here. So you think about it. I've gone around 7 pi over 4. What's left? 1 pi over 4. That's all that's left, and there's your reference angle. So theta reference is going to be pi over 4. The reason why is because you want the smallest angle to the x-axis. One more chance to get it. If not, back up the podcast and watch it again. Let's do this last one here, okay? The last one, see if we can figure it out. Minus 13 pi over 6. Look at that. There's 12 pi over 6. So let's draw it. Boom, boom. Starting backwards. There's your 12 pi over 6, right? That's backwards, 12 pi over 6. So obviously, that's going another pi over 6. You've gone over pi over 6, haven't you? You've gone one more pi over 6 downwards. But the reference angle is always positive to the x-axis. This, in fact, is a reference angle of pi over 6. That's what you would use in all the calculations and determining everything, every value that we're going to figure out later on. Those positive reference angles becomes hugely important.